Okay, we will just record the presentation so everybody in the future can maybe rewatch the presentation.
Yeah.
If you don't want your face on it, then maybe you shut off your camera for this.
So today's topic is about extraneous water prevention in drainage systems. So, short introduction to wastewater talk. This program will present a new topic every month for discussion, and our goal is to exchange knowledge in wastewater field and share our passion with you. And most importantly, we want to get to know you, all the like-minded people as us. And if you have followed Polytechnics or Classic on LinkedIn, you might know that we also have another program called WASTEWATER-TALK. It's in German. If you can understand German, you can also feel free to check about it. So here we have an episode overview that today is about extraneous water, and next month we will discuss about indirect discharge investigation in the sewer system. And also we have the plan all the way till June, where we will have a special episode about IFAT this year in Munich. If you will attend IFAT, or you are interested in what was new in IFAT, please follow us. Yeah. So now I would like to ask Marcel to introduce about the smart pipe from Anticimex.
Yeah, thank you very much.
Okay.
Maybe we will explain a little bit. We want to also give other people here the chance to present issues that might be of interest. And we had last time the issue about rat control, and that's actually from 2 weeks back or 2 episodes back. But it's maybe an interesting issue. So if we would put this into this discussion, and if you have other issues in the future that would be also maybe interesting for all of you guys, then we always want to give this platform. Okay, so Marcel.
Yeah, I hope you can see the screen I've shared now.
Yes.
Yeah, we can see it.
Okay, thank you, Mark. Yeah, first of all, thanks for having me. I will talk some minutes about the solutions Anticimex offers, for rats in the sewer. So my name is Marcel Scheel, Smart City Specialist from Anticimex, the Netherlands. First, short about Anticimex. In the Netherlands, we have about 200 employees. We have 5 offices. We're number 1 in the Netherlands and worldwide. If you look at a smart pest control, so the smart linked devices, we have 8 certificates, and we're active in 19 countries, also in Germany and Austria, more countries in Europe. The rats in the sewer. Why are there rats in the sewer? Rats have some basic needs, which is food, stable temperature, and protection, and the lack of predators. And that's all they can find in the sewer, because the eating is flowing away, on a daily basis. So they have everything they need there, and there are more benefits. It's basically a transportation system which they can run through the whole city, and there are also dry locations in where they can make nests. And as a result, because of the population is growing and growing, and they have need for more space and food, they get out of the sewer system. And if they can find food and shelter above ground, that's causing problems in cities. The problems which they cause are the health issues. They can bring in bacteria and viruses. Of course, there's a material and financial damage, because they have to use their.
I'm sorry, we want to cancel this the sound of this other person. Where is he? Now again, Marcel, can you please open your mic?
Yeah.
Sorry, that was our mistake.
Okay, no problem. It happens me also sometimes. Yeah, they're causing damage because they have to keep using their teeth in the sewers, as they keep biting on everything, and it makes life harder for inhabitants of the city. Yeah, we did international research. Where do people see rats? Yeah, most of it is outdoors, but also sometimes indoors. But when you look at these places, it's all above ground, and nobody really knows the number of rats, the population underground. So that's hard to control when you can't measure. We also asked if people see a decrease and increase, and many people see an increase in the rat population and also the problems they cause. Yeah, all of this, more of this research is to be found on our website. So what we have is a smart rat trap, which we placed in a manhole in the sewer on strategic locations. This here you see the connection to the main sewer. There we place the device. When a rat passes, it gets detected, and there are some flattened pins who crush the rats. We also always have to place multiple, because you have to really catch the rats between multiple points, otherwise they'll escape via another route. So we can place them in an area. The data is sent to our location, and when the numbers are dropping, there's no more rat activity, we can place the traps further up, and then we can clean that area. So a rat passes, get detected, the pins shoot out at a very high speed, immediately kills the rat, and the pins go back in, and the trap is ready for the next rat to pass, and the dead rat just floats away or gets eaten by its brothers. So with this method, we can clean out complete areas and then move up to the next area. So here are some more pictures of it. Yeah, the way we start, we always do our research with the city. We do preliminary investigations. We agree on what targets we should focus for with the city. It's not an option to completely just kill every rat, and it's also not necessary. We also look at the notifications from rats by residents. Yeah, this is a video of how we place it. We always have to take our safety measures, so the people have the right papers and the right schooling, so they can do that in a safe way. So they do not have to get into the sewer. They lower it, and there the device connects itself to the sewer pipe, and we digitally registrate it where we have placed it. So the city knows also where the devices have been placed. Yeah, it comes with a monitor, so when it's installed, it's basically, we have to maintain it once in a while, because when the battery is out, we get a signal, and then we can repair it. So we get the data from the traps that's sent to our location, and we make reports on a weekly basis, whatever the city wants. So we can get information on the population and when it's decreasing. It's a solution used worldwide, also in the US, in Europe, and various places, because there are rats in every sewer all around the world. So there are over 12,000 of these devices active at this moment. That's basically it for now. There's more information to be found on our Smart City Pest Control website, and we'll do a webinar in Dutch later this month. So that's it for now.
Okay, Marcel, thank you for your input. If there's somebody interested in more about rats, then you can go onto the website 2 episodes back. Then you find a small presentation also with some more information and also a recording, I think, about the meeting back then. Are there questions in this round? We are 17 people now, I see. So very good. Now there are coming some more all the time. Now 18, very good. We are happy with this. And is there questions about this smart pipe from anybody here? Then open your mic and ask.
I have one actually, because especially in the city, you have some control operations with, for example, some evac drones. Do you have a way not to crush the tethered drones that are already inspecting, or at least does the operator of such drone have a way to see for himself that he's going inside the trap?
You're very hard to understand, but I heard that you are afraid that your drone will be crushed by the.
I don't think ours, because they are for really big sized sewers, but I'm thinking more of the standard operations in personal sewers that happen every day. So
that is why we tell the city where our pipes are, and there's also a safety device in it. So when you're opening the lid, it sees daylight, and then it's also disabled. So, but all the people who are working on the sewer, they are informed by the city where our traps are, and we also mark it on street level, so they know where it is.
Okay, yeah. So that's pretty safe.
Yeah.
Okay, so if there are more questions, then your contact information is here. Marcel, if you want to send us your presentation, then we can also upload it to the web page, and maybe somebody can contact you afterwards.
Yeah, thank you very much for the time and for everything.
Okay.
Yeah. The back to our presentation.
If there's anybody here in the round who has something else to present, then maybe he can write Ziki an email, and she can make a small time for you in the next wastewater talk.
Yes.
Okay.
So before we jump into our topic today, a short introduction about Unitechnics also. So we are an engineering company based in Germany. We deal with all the problems in the sewer systems. The company is grounded since 1990, and since 2000 we started developing and also producing the products against odor and corrosion in sewer systems. So here's a range of the products and services we offer. We do engineering consulting. We also investigate indirect discharger for the cities. We also inspect sewer systems with drones and camera boats. This we have covered in our last episode. If you are interested in it, feel free to check it on YouTube. We have a recording of it. We also offer software balance calculation for the city sewer systems. Also, we have some products against odor, corrosion, and extraneous water, which is our topic today. For the special cases, we can build some dosing systems or exhaust air treatment facilities, and we have rat control. This is also covered in our first episode, and you can check it on the YouTube. So now we will dive into our topic today, the extraneous water intrusion. So when we talk about extraneous water, actually we can't really see it unless we do an inspection in our sewers. That's also why when I search for the extraneous water online, you can only find the photos which are from the sewer inspection. So you can see that there's some water jets coming into our sewer pipes, or there's some pipe joint which is not, you can't find it on our plan. So what is exactly extraneous water? There are so many definitions of it. In general, it has multiple sources. The extraneous water comes from groundwater, stormwater, or running connected drainage. And the entrance of extraneous water is unauthorized. It comes from defective pipes, from joints, or from the manholes, especially with the ventilation holes. The extraneous water also has different qualities than the sewage, which means it is not contaminated by the domestic, industrial, agricultural, and any other usage, and it is unwanted in our sewer systems, which means they should not be there. So what kind of sources are there for our extraneous water? The first one is groundwater, especially when the groundwater level is relatively high and higher than our sewage level. It can also be from the stormwater when there is a pipe connecting between the storm sewer and the sanitary sewer. Also, it could be from the spring water or illegally discharged drainage water, household leakage, drainage systems of building foundations or property areas, as well as streams from water drain during construction, renovation, or cleaning works on the streets. And when we talk about unauthorized entries, it could be the leaky manholes cover all the frames, or there's deteriorated manholes, which means there's cracks or damages on our shaft and pipes. And from a study about extraneous water, it reveals that over 40% of the reasons that we have extraneous water intrusion is from cracks on our pipes or the shafts. And there's also nearly 28% of the reasons are from displacement of the joints of the whole sewer systems. So what kind of impacts are there when we have extraneous water intrusion? There are two aspects. First is on our sewer systems. When there's too much extraneous water intruding into our sewer systems, the manifold increase, it will create a manifold increase in our sewage flow rate. And our gravity sewer system will be operated under pressure, which is unwanted. And the backflow, and there could be a backflow into our basements or underground infrastructure facilities. And on the other side, in performance of wastewater treatment plants, the periodical hydraulic overload of the technological facility
I did lose them.
Yeah, we lost them also.
Yeah.
We are back. I don't know why. Guys, sorry.
Welcome back.
Sorry,
Yeah.
we have to go back to the slide. Where we went? This one?
Yeah,
No,
we can start this one.
this one. Yeah. We are back. Sorry, we had an internet problem in the high technology country Germany here. That's very high technology. Okay.
Yeah. So what we can do against extraneous water intrusion? Well, we identified there's 3 things we can do. First, we can proactively inspect our sewer systems in a regular manner, so that we can identify all the sewer, well, not all, but we can identify the sewer cracks in our sewer systems and repair them as soon as possible. And in the last episode, we covered about this topic, the sewer inspection using innovative methods, for example, the drone and camera boat. And if you are interested in it, you can check the video recorded here. And what else we can do? We can also conduct analysis of extraneous water flow in our sewer systems by using a radar sensor. And this we will also cover in our 5th episode in March. And by measuring the level of the sewage level in our sewer systems,
So, okay, now the screen is also back, right? So,
Yeah, yes, Klaus.
I'm very sorry. Now, this is the level measuring that we mean. That was the drone inspection, and it's the level measuring that
the flow rate in sewer systems. And we can create a whole network for the city. And by clicking every sewer pipes, we can know exactly how much water is flowing in our sewer pipes in the real time. And in this way, we can have an analysis of how much extraneous water are in our sewer pipes. And when there is already the problem of extraneous water intrusion, especially in Germany, when we have the manhole covers with the ventilation holes, we can use a product to shut out the extraneous water from getting into our sewer systems. So here is an extraneous water shutoff system, which functions like this. In the dry time, the ventilation of the air is not prohibited, and during stormwater time, this shutoff system will stop the water entering our shaft. And when the water gets away from our streets, the shutoff system can let the air ventilation function again. So before using this shutoff system, when there's 1 centimeter overflow on the streets, we can have 4.7 liters per second extraneous water entering our shafts. After using these shutoff systems, we can control this entering flow rate at about 0.1 liter per second, and this is like 50 times control rate. So it's really useful. And yeah, that's our introduction into this topic from our side. And we would like to know what kind of extraneous water intrusion and how serious is this problem in your country, in your region, and what kind of countermeasures are you using? So we can now have a discussion about this problem.
We'll just stop our slides for now. Yeah. Maybe in our round, how about you guys? Do you know about this issue in your country? Maris, Mr. Zviedris, I hope this was still correct. How is it in Riga? How do you do that in Riga about this issue?
Yeah, we are right now on the way that we are trying to develop some modeling a system for our sewage network, and it takes some time and will be ready next year, not 2020 but 23. Yeah, and right now we are monitoring groundwater, we are monitoring this rainfall and calculating water which have intrusion in our system. Of course, there are some common solutions, like in all other Europe. We are monitoring our manholes and sewer network, and we have plans for repairing like 160 kilometers of the pipes which are in a critical situation, and out of 1,200 it's like 10 to 15%. Yeah.
Okay.
So, and this flow analysis with dry weather and stormy weather flows, these are also analyzed. But one interesting question was raised some years ago when we stick to American way for calculating this infiltration. Yeah, this is like a COD dilution.
Yeah.
And, if we compare this water amount which is brought to the potable water network and comparing it with dry weather and stormy weather conditions, then according this to COD measurements, online or laboratory measurements, we could predict how much it is diluted during those storm events or spring water or high level of groundwater and so on. But this work is not done because we know exactly where we are getting a lot of water in this damaged pipelines. Yeah, we are more interesting right now in investments which takes far more than like 70 to 100 million euros in our sewage network only. That's it for now.
It's a big issue when the treatment plant is on a high level, then the focus shifts a little bit to the sewer network afterwards, because that's delivering the water, right? And if the COD is diluted, then you get problems on the sewer, on the treatment plant, or is that a problem in Riga also?
Yep. Let's consider this water in this case like transporting means. Yeah, and if normally 1 people equivalent is producing like 60 grams of BOD, or accordingly also COD, then by diluting those concentrations, we could, let's say, have more diluted water. But at the same time, we should analyze these curves which are showing us how rapid this water intrusion is. Yeah? Does rainfall is rapid enough, like 2 hours or 1 hour, all those millimeters of rainfall we are getting in the sewer, or is it splitted during the whole day? Yeah, and therefore we are not getting so much trouble with hydraulic overload because our network is quite large. according to former Soviet standards, we were using much more water previously. So we are able to steer with this network some hydraulic loads, peak loads. Yeah. Therefore, this is not an issue, but the treatment plant is working with let's say double so high flows compared to dry weather flows. Yeah, this is the issue, of course. Yeah.
There was a quick question by somebody in the chat. COD means chemical oxygen demand, and it's a measurement for the the amount of organic material that has to be cleaned in sewage water. So the higher the COD, the more polluted is the water. And
exactly.
if you have a lot of extraneous water, then you have high clear water in it, right? And then the COD is lower, and that is not good for the cleaning process on the treatment plant. I would have one more question. You said you have a lot of combined sewers in Riga. Is that correct? Is it? I heard it in Eastern Europe. There is more like, because I'm from East Germany too. We also have a lot of separated sewers because of the Russian influx we had back then.
We have those combined network, but it's not a lot of them. Let's say this number is like 25 to 30%, and it's mainly like old part of the city where it's quite hard to rebuild them. Yeah.
All of outside of the city is more like separated, right?
Yeah, that's right.
And inside, that's the same with us in East Germany also. And the more south we come in Germany, we have more combined sewers, and also Western. We have like an equator in Germany. We have like half of Germany is more combined sewers, and the northeastern part we have more separated sewers. And I learned that the far eastern I come in Europe, then I have more separated systems. And then you have a problem in the sewers when you have a lot of extraneous water, right?
Right.
What about all the other guys? Do you have? You saw this system that Siki showed about the manholes. Do you all have manhole covers with holes, or is it only in Germany? That's the question. We have these covers with concrete in the middle and 16 holes like this big in it for ventilation. And we have a lot of infiltration of water inside of these holes.
This is not common in Latvia, no. We have some those very heavy, like 100 kilograms, those thick covers left somewhere, but not many of them. We are exchanging mainly to this 60-ton capacity covers, which are completely closed. Yeah? We don't have this problem, which were shown. Yeah. Otherwise, we have those rain collecting manholes, yeah, which sometimes are without permit connected to the sewer. That's another issue.
Okay. That's the same everywhere. Okay, great.
In the Netherlands, as far as I know, we do not have the little holes in the covers.
Also not, okay. How's another, maybe?
And in the older cities, we also have the combined sewers, which is more better. Perfect situation for rats, of course, because they can get in and out everywhere, and they can even climb into the toilet and get out sometimes.
Okay. And Isan, you said we have the same in Iran. Okay. It's the same issue with you guys also. Elias, how is it with you?
Yes, hello from Switzerland. Yes, we have a lot of combined sewer. We are trying to build separate sewer if we build something new, but usually it's combined. And I never heard about this problem that with the holes that there is coming water inside, but the problem in general is a huge problem, and it's not just, I think it's not just a problem for the treatment station, it's also a problem for the rain overflows. In combined sewer, I think it's the same all over the world. You have the overflows into the rivers and lakes and sea. And so the problem with the, how do you call it, with the proper water, or like the
extraneous water, we said. I hope that's the correct term.
Yes, we call it Fremdwasser. So
yeah,
it's
in Germany we call it Fremdwasser. Yeah,
Fremdwasser, yeah. So I'll use this term. It's easier for me. So if you have a lot of Fremdwasser in a system, then we have a problem at these overflows, because the amount of the actually diluted water that goes to the treatment station is less than it should be. So you have more overflows into the rivers, and I think that's a huge problem. In Switzerland, we say that depending on where you are, you have 30 up to 60% of Fremdwasser in your system. So more than half of the water is not actually polluted. And I think that's the reason why you should take measures against it.
Where exactly are you from in Switzerland? Where are you from?
Bern, from Bern.
From the city, or?
Bern, yeah. Capital, yes.
Yeah, okay, cool. Yeah, and anybody else who wants to join in, maybe? How is it in the hot country? We have somebody from Iran. Ehsan, but we have separated system for rain and sewage, you said. In winter, we have problems with basements.
Yeah, we have a separate system. Thank you for the time. We have the separate system, and as you mentioned, we have problem with, I mean, in the winter with basement and some, especially the old part of the town, we have a problem and people annoyed. But there is another problem too. We have an old method of water. I mean, the name is Qanat. Maybe you know about that. There is some channels underground in the old time, go water through that, and people in every house has a small area, and the water go like underground river. You can imagine, and from the mountain to the city, and there are so much from this, I mean, the channels, and these channels nowadays penetrate to this server network. I mean, it's a big issue too. And in the south of the city, some farmers maybe have farms and use this water for drainage and something like that. And the problem is more and more with this old water drainage system too.
Because of the pollution, or because of overflow?
Because of the overflow, because the level of these channels sometimes is upper than the level of the pipes for sewer collection, and it can infiltration can happen.
Okay, so everybody has its own problems with this. What if you could make a wish on a solution that you would need for these issues? What would be that? I mean, we all said, okay, we have problems with this. What is your measurements you take? I mean, Mr. Swieders already said he makes simulations. I believe maybe in Bern and maybe Iran, you already also do that, right? Like hydraulical models of the system and so on.
For the modeling, as I know up to now, for the sewer system, can you hear me?
Now again.
Okay. For the modeling up to now, for the pipe network that is under operation, we have some kind of models. I mean, maybe commercial models like water gems for water network, but for sewer network, I mean the network that is under operation, up to now, we do not have some kind of modeling in Iran. I mean, because it needs some kind of data, exact type of the depths and the pipe material and the pipe and something pipe diameter, and sometimes we do not have enough data to have a good model that should be calibrated and verified and can work properly. We do not have any sample of that, but maybe in ongoing years, people started to collect this data and digitize them, and after that have a model.
That's actually what Ziki chose. Maybe I go back to this slide. We went over it a little bit with the problems for us. I think for us, we are working on this like for 2 years now, using this radar stuff you can see here. And for us, that's a solution that we are working on in the city of Karlsruhe at the moment, where we are making some test installations all over the city. And we don't make an exact measurement of everything, not the exact simulation of everything, but we want to have, because these radar drones are very cheap now, with the it's like some kind of 1,000 euros per measuring point. And if you have a lot more, then it will get cheaper in the future. And then you have, like on the left side, you can see, or in the middle, you can see this measuring where you can see, okay, this is a normal day curve here in the night, and then you have a daytime, and then the night again, and then if you have a rain event, then you can see, okay, the level is different. And we want to use that to have data from, like, the battery duration is over a year, and then you have like a measurement that we install forever, like 5 years. And then you can always say, okay, how was the rain event like last year, and how full was my channel in this point? And then you can also make artificial intelligence predictions between the measuring equipment and say, okay, during this rain event, how full is my channel in this point, and where is my exact hydraulical problems? Because the models we have is always a problem that they are very, not very exact, because there's a lot of factors in huge sewer networks that make it very inaccurate. That is what we found out in the past. Somebody drew a line. Who did that? Maybe that's an interesting issue that we are exploring at the moment. Is there somebody of you guys who already uses something like this? Flow metering by radar? That would be interesting for us.
Is it like a level measurement or already calculation for a flow? We have different systems in Germany. We have systems that measure velocity of the water as well as level and velocity. And then you can say, if you have the diameter of the pipe, then you can say the water amount was Q is this high, liters per second or something. The problem is that you have to have high costs. The battery times are very low, and you have high installation costs because you have to get in there and put the sensor in. And what we are trying is to use only level, and then say, okay, I have the diameter of the pipe, and I have the incrementation, the steepness of the pipe. And with all of that, I have not this exact measurement, but the cost is a tenth lower, so not 10,000 euros, but 1,000 euros. And then I can install like 10 meters,
where I could only install one in the past. That was only 2 months, and now I can install 10 for 1 year for the same cost. And it's a little less accurate, but in the whole, it's a swarm intelligence. You have a lot more measuring points that are not very exact, but you have exact heights. And we are expecting that we have a better overview about these huge sewer networks. That's what we think. And we are trying now in some cities in Germany that are starting this with us. And we want to know if it's maybe outside of Germany, anybody has already experience with something like that, because we are just making our experience with this.
Yeah, I know that in the Netherlands, there's also a company who has the smart man covers, which can detect also flow, and they can also detect chemical substances. So if they want to see in an area if there is a drug production, illegal drug production, where they dump materials in the sewer, they can place those sensors in strategic places and use also that for more of a police task to get information. But I'm not sure if that's only a proof of concept phase or if they're already using it.
Okay, it can be helpful for modeling in sewer gens.
Actually, in Riga is the system is that area is quite flat, and we have like 80 pumping stations. So this flow measurement from each small basin is measured through these pumps. Yeah.
Okay.
But this doesn't give exact figures and information for model. Yeah. It's better to measure those inflow to this pumping station and intensity of the rain and intensity of the water. And I'm afraid if you on your picture measuring also only this level for manhole which is floated, yeah, that doesn't give you figures about flow. Yeah. That's maybe not the right issue.
We tested that against other methods. It's very accurate if you have not a backflush. If you have a backflush, then you only have level, and then you cannot say how if you don't have a free flow in the sewer, then you don't have exact velocity anymore.
Yeah, this measurement of the level is correct if you have a half empty pipe, let's say, and then it's okay. Yeah, of course. Yeah. Or channel or whatever.
Yeah. Yeah. That's also what we found out, and we say we are now trying. If we have a full pipe, then you have a pressure in the pipe, and then we are trying to maybe calculate with the height in the pipe the pressure that you have in the pipe, and then we can also maybe get a flow. But this is experimental at the moment, and we'll see about that. We have a portal a little bit where we can put all the data together, and our experts on programming at the moment trying to come up with an algorithm for this somehow. But we'll see in the future. Maybe in another episode of Wastewater Talk we can present this. Yeah.
How many points of measurements you have?
We have some. We have in Karlsruhe we have 12 now, or we are installing 12 now in January, February. In other cities we have like 10, or everybody's testing, and then in Berlin, I know Berlin Water, they are trying to install 150 in a small part of Berlin for testing at the moment. They are already a little bit further with this. They tried some techniques, ultrasound and radar and other stuff, and they are really hoping to cut the cost for level or flow metering by this level metering only. But it's somehow a little bit experimental yet, and the progress depends on on two things: on the cost of the installations. So if the sensors get less expensive with all these IoT, Internet of Things stuff at the moment, and I think if IFAT happens, we will learn a lot more about all of these technologies. If that gets less expensive, then I can install much more sensors inside the sewers. And the second is the algorithm that we need. So the level is only a distance. Then we have to find out how the level, how I get from a level to a flow a little bit. That's like you said, Mr. Sviedrus, I hope it's still correct. Like you said, it's not that accurate, but if you have more places, then you get a swarm intelligence picture a little bit. That's what we hope, at least.
And may I ask about the man cover you showed with the overflows, which preventing water from getting out? That's not a, let's say, electronical smart device, just working by the flow of it.
You mean this part here?
Yeah.
This is not to let water out. It's to prevent water from getting in.
Yeah. Yes. That's what there's no sensor or electronics in that can also give data from this.
We produced that 5 years ago. We tried that. We can make a magnet sensor on this flow plate here inside, and then we can detect when it's closed and opened. But there was actually not a lot of customers interested in this. But maybe in the future, if it gets cheaper, then maybe.
And if there's a very high, heavy load of water, can it push out the man cover to the street?
If the water comes from below, yes. But there's also variants that you can put this in and make chains here on the manhole and then prevent this from getting out. That's also something that we already built. Yes, it's possible. That's actually something that only makes sense for our turn from separated systems. And only if you have manhole covers with holes.
Yeah.
I mean, you can look on the online website. There are also variants that are without this ventilation, that's fully closed. It's also there, and you can also fix it with screws so it prevents water from coming out. Always depends on how much water level you have, how much pressure it generates, right? That's answering your question, hopefully.
Yeah. Thank you. Our smart trap does also have a sensor in for the water level, but it's only on the top. So that's to measure from a distance if the device has fallen or something, or very high water. That's not a level measure, just on or off. And we can also, I think, measure temperature.
Temperature is always a part of all these smart stuff. Well, temperature is not that important, that expensive to measure. Is there anything else anybody wants to bring into the discussion today? Because we already have 1 hour, I think. Or is there any wish for maybe that we could explore for next time about these issues? Or anything that you would maybe expect to know about the extraneous water stuff that maybe we can work on and maybe next time discuss further?
I would be interested in this manufacturers of this covers which are floating, and most probably I have missed this other issues which were previously discussed in a sewer network.
You mean odor issues or odor?
Have you discussed already other issues in
the very first small where we tried something like this? This was the very first unofficial wastewater talk. We had an odor discussion.
Okay.
But maybe next time we can put it on the agenda again.
I think it's already on the agenda.
Or maybe have we it on the agenda again?
It's in the episode overview here. I think this
It will be in but this is March. No, that's January, February, March. In May.
We'll talk about the audio.
Can you wait until May?
Yeah. It's no problem, of course.
I mean, that's we will discuss there a little bit. Sulfide balance is like a hydraulic simulation of sewer networks, but we can also simulate. If we have a hydraulic simulation, we can simulate odors in sewer systems with this system. Maybe next time we go 5 minutes. That's actually, we want to be a little variable on this, flexible on this. So maybe next time we can discuss a little bit about 5 minutes about odors again, and maybe make a short introduction in the issue. Or if you want to discuss, we can also just schedule a short meeting about this and discuss it a little bit. I mean, it's always a very problem if you have a lot of pumping stations. You said you have 80 pumping stations, and you maybe are familiar with longer pressure pipes and the issues that arise from this, right?
Right.
Yeah, that's actually an issue that we also know from Tallinn, from Mr. Core there. I don't know if you have, it's also Baltic state there, and they also have a lot of separated systems up there, and we have in East Germany also a lot of these issues. That's actually why we are a company from East Germany, because the odor issue was a big issue for our company in the after reunification years in Germany, because we changed our water consumption a lot after that. Yeah. Okay.
I also, Klaus, do you hear me?
Yeah.
I also have like a suggestion, or I would like to know more about the rainwater basins. So if we are talking about the extraneous water, I would like to know more about the rainwater basins, where we collect the storm water in it, and then we use this water for irrigation or for whatever.
Okay, we include this in the 5 live flow monitoring. Okay.
We can also have an episode.
Yeah. Okay.
Yeah. That's. I knew that you worked already in some project for like rainwater basins. So if you can just give a brief, like, I don't know, 10 minutes about the kinds of rainwater basins, and how do we need to do a treatment for this water or not, and how can we use this after? Is it just irrigation, or we can use the water for like drinking water and whatever?
I mean, we can always only show our side of the story. If there's, maybe we find somebody else who can discuss a little bit about this, who is not Unitechnics, because there are other experts on this.
I know it's promoted in the Netherlands also for households to keep their collect their rain from the roof and irrigate their garden with it. But that is, if you have a normal tank in your garden, that's causing mosquito problems, because if it's still water for over 24 hours, yeah, the mosquitoes love it. So that's and also the we have in the Netherlands, they're called WADI, the temporary water irrigation areas, just small, dry areas in the city where when the high water flow is collected there and have to get into the ground. It's also a climate adaptive measure. It's also a risk for a potential pest. So that's
for mosquito pest. Anything else wishes that you might have? that we can integrate in the schedule, maybe. Yeah, okay, then we are left. Mr. Streeters, you want to address something? Because you, no? Okay. We want to say thank you for the lot of, I think in the peak we were 18 people today. We are very happy with this. And also for all the new people joining us today, what very nice that you were also are very active in the discussion, and we will try to always improve our presentation and discussion methods a little bit, and also our internet connection. Very sorry about that. And next time the main issue will be indirect discharger. Maybe we say some indirect discharger is also maybe the odor issue. We can integrate this a little bit, because that's a lot of the time you get the first problem with the indirect discharger with the odor. And if you so will, pumping station is also an indirect discharger, maybe. And then maybe we can, we would be happy if you maybe want to join next time. If you have some to say yourself about this, then we would be happy to share our screen or your screen to the people here. You can talk freely about what you want to talk, and we are very happy if we get a discussion going, international discussion going. Yeah.
Thank you, everybody, for joining us today.
Yeah. Next.
Thank you. See you on February. Otherwise, on Munich, in EFAT.
Yeah, in EFAT, we very, very much hope it will be happening.
Hopefully.
We have a booth there. If you want to join us there, we will present our drone and odors and everything else we do and sell for a lot of money. And we will also have German beer and whatever there, I think, and something to eat maybe also. We'll see.
Good to know. See you. Bye bye.
Thank you very much.
Thank you all. Bye.
Have a nice day. Bye bye.
Bye.